Hello there, guys. So, I told you that I would make you a video about some of the plankton organisms that I've asked you to look up. So, today, I shall look at the dinoflagellate. Notice here that I've typed in dinoflagellate into the search menu, and what has come up is this great little wiki. I know sometimes wikis aren't the best, but let's look at this wiki. The dinoflagellates, Greek for dinos, meaning whirling, and Latin flagellum, whip, scourge. A single-celled eukaryote. What's a eukaryote again? Eukaryotes, remember, are... Did I just switch to Irish right there? What happened? Hey, the single-celled eukaryotes. Eukaryotes, remember, are much like prokaryotes, except eukaryotes, they have a nucleus and membrane-bound organelles. Prokaryotes do not have a nucleus. Alright, so anyway, you got single-celled eukaryotes. Notice you got most of your stuff right here. They're single-celled eukaryotes consisting of flagellum, dinoflagellata. Usually they're considered algae. They're mostly marine plankton, but they're also common in freshwater habitats. Their populations are distributed depending on the sea surface temperature, salinity, and depth. So if we wanted to look up this wiki, we could continue reading. It says that most of them are photosynthetic. A fraction of them are mixotrophic. Mixotrophic is an organism that can use a mix of different sources of energy and carbon. Instead of living a single trophic mode, they continue complete autotrophy and then heterotrophy at the other. So some of them can do photosynthesis on one side and eat on the other, which is interesting. Some of them will eat actual prey. So these guys then are photosynthetic, and so they're going to be zooplankton. You could call them some phyto, some zoo, because they can cross over into both. So notice that dinoflagellate isn't one organism. It's an umbrella of a lot of different organisms. This is just a phylum. Remember, kingdom, phylum, class, order, genus, species, family, order, genus, species. You have to get all the way to species to be a singular organism. This is a phylum, so there's multiple organisms in it. Says that some of them are endosymbionts, meaning that they live inside of organisms and stuff. They're substantially smaller than diatoms. Diatoms is one we need to talk about, so maybe we'll click on that after. And then it basically talks about blah blah blah. This red tide one, they can cause this thing called red tide, which is an algae bloom that produces toxins. It can kill fish in that area. They can also do bioluminescence, which is where they emit their own light. So like a firefly does bioluminescence. They typically will emit a blue-green light. In fact, there's some, usually when they get stirred up, is when they emit that light. And these were actually used in World War II. Planes leaving aircraft carriers would go out, and as they started honing in on trails in the water of this glowing algal bloom, the dinoflagellates that were glowing, they would then follow that trail to a ship, bomb it, and then return back to base, as it were. But anyway, that's that. You could also look in here. There's habitats, so it kind of gives you kind of where we're at, and then our nutritional strategies. And then really where we want to get is we kind of want to get, there's their life cycle, glorious. So notice it's all here. And really the examples, you might want to look at some of these examples to see some of their structures. You could also grab a picture off of here, but that would help us kind of find some different examples. If you don't see anything about adaptations on here, you might actually look them up, but really the adaptations on these guys, they have, most of them have kind of hard shells and soft internal bodies, so the hard shell kind of helps protect them, and then the whip-like tail allows it to move, so it can actually seek prey, or it can actually, if it has the photosynthetic side, it can actually seek light, so it can actually swim to some degree towards light. So those would all be adaptations that would help this guy survive and reproduce. Wherever its reproduction was, it talks about how it does binary fission, which is where it essentially splits in half and then regenerates. Each half regenerates a new half. So that is kind of how it reproduces. It's an asexual form of reproduction, which basically over time, if it gets to the point where it is in an environment that's conducive enough for it to reproduce, then it will reproduce a lot, and then we get that thing that's called an algal bloom, which then can be harmful to other organisms, but obviously is whatever. So that would be kind of the stuff that I would look for on one of these, and then if we did that, we could always come back, and Diatoms is on right here, right? We could click on Diatoms and kind of same thing. It walks us through this, and it'll talk about what they are. A lot of them are made of silicone, which is what we get is the primary constituent of sand. So there's this stuff called diatomaceous earth that we can put in our gardens that like snails and stuff don't like, because it's really, really microscopic, and it gets stuck on them and they don't like it. A lot of it's actually a it can kill some small garden pests, and then it's also because it's silica, it's sand, so it's actually an amendment for your garden as well. Anyway, so you kind of go through this stuff, and again, same things here. Structures, it'll talk about some of them have flagella, which again will allow them to swim towards light if they are photosynthetic, or swim to capture things. So kind of read about those dudes, figure out what's there that you like. The other thing is, a lot of these dudes are photosynthetic, and if you look at like kind of some of these pictures, a lot of them have like spines and stuff, which if you could imagine, if it's in a water column and it's got spines all over it, that actually adds surface area to, as this thing starts to sink, it's kind of like a parachuter that puts his arms out, right? It can slow your fall down a little bit, so it keeps them in the photic zone a little bit longer. Anyway, you know, look at it. Cell division. Some of them are sexual. They have sperm motility, and then their ecology, where they live, what their impacts are, is probably good to know. That being the case, that gives you dinoflagellates and diatoms today. Let me look up one more here. I'm just gonna stay on Wikipedia. Go against our English teachers' ideas. Here is a Daphnia, and this is a genus of small planktonic crustaceans. These little guys, again, it's a genus, so now we're a little bit more narrowed down. It's not as big a phylum as, say, those diatoms or the dinoflagellates, but this is a Daphnia. They're sometimes called water fleas, and it has little appendages that if you were actually here and able to look at one under a microscope, they can swim. So they're able to swim, and then this dude, what's cool about him is he has eggs right back here. So this one is a female. It has eggs, and then this little thing that looks like an egg too is actually its heart, and you can actually see its heartbeat if you were here in person. So inside of here, it has a bunch of legs that can swim around, and then this whole body cavity, kind of its belly looking, is like a clamshell that opens up, exposing those legs, and then those legs. So it can actually swim pretty good, and then it has this eye spot, so it can actually swim towards the light. It can also see prey, capture prey, and it has a mouth, and it will eat those things. And then this is its digestive system, and you can actually watch it poop those things too. So this guy is multicellular. He's still microscopic. He is visible to the naked eye. You could actually see these guys and even make out some small detail, like you can see their little arms fluttering about, and you can see their eye spot. But that's about all you can see visually with the naked eye. When you get them under the microscope, this is how they look, and you can see some of those actual body features and stuff. So read about those guys too. These guys would be zooplankton. Typically they are freshwater I'm not sure. I don't know of any saltwater ones, but if you read about it, you might find some. It looks like acidic swamps to freshwater lakes, so most of them are freshwater. Anyway, they are zooplankton. They search for food. There's their life cycle. They have eggs, and then they hatch, and then yada yada yada. And so, read about that. You can paste in pictures if you want. Not write about it. It's up to you. But again, they'll be in there. And then it's up to you as to what you want to add in there. Notice rotifers are also one that's on our list, so you could pull that one up. Most of these guys are in Wikipedia. Most of these guys, Wikipedia will kind of give you all the information you need to know. These are one of my favorites. They're kind of cool, so look about them, put what you need in there, and see what you get. Remember, we're looking for adaptations for the most part in these descriptions. So what are some things that it does that allows it to, as a species, survive and reproduce on the whole? So if you have any questions about those, I just went over 3: diatoms, dinoflagellates, Daphnia. I know I didn't give you everything there, but I did give you kind of a pointer into where to find those. So consider that day 1, video 1. Next time I'll hit a few more, and maybe hit 3 at a time, and then that'll be 4 videos that you need to watch. So there's that. I will see you on the next video. Until then, have fun.